PDF files. The answer is out there.
The Microsoft Fabric Certification Podcast with Kevin and Frank.
Episode 5. Reloaded Regret.
I have a question. Your company experiences performance issues with its current ETL process, which involves loading large volumes of sales data into a fact table in a Microsoft Fabric data warehouse. The process currently uses a full reload strategy, which is time-consuming and resource-intensive. You need to enhance the ETL process to boost performance and decrease resource usage. Each correct answer presents part of the solution. Which 2 actions should you take? Select all answers that apply. A. Continue full reloads with increased compute resources. B. Implement an incremental load strategy. C. Manually partition the fact table. D. Switch to Azure. Data Factory for ETLE. Use change data capture. C, D, C for tracking changes.
Hey Kevin, how are you doing?
Good, thanks, Frank. Yourself?
Yeah, I'm fine, thank you. So, you heard we got another call from the lady and she was asking about ETL again, right? And about performance issues with the ETL process. So, what do you think about this? So, what we have to do is we have to enhance the ETL process to boost the performance and to decrease resource usage. And in this case, again, it is a question where we have multiple right answers. So in this case, 2 answers we should select. So shall we go through all the answers and work out what's right and what is wrong as we proceed? So let's start. So the first answer would be continue full reloads with increased compute resources. How are we feeling about this, Kevin? What do you think?
Well, the actual ask from the lady was to actually decrease the resources. So to be honest with you, this will not be the answer that anybody is looking for.
Yes, because if we increase, we do exactly the opposite of the woman is asking, right? So, okay. So yeah. I think we are very safe to say that A will not be an answer at all to this. Okay. So, yeah. But what we could do is we could implement an incremental load strategy. So as always, I don't know so much stuff. So could you please explain an incremental load strategy? What is this? What do I have to think about an incremental load strategy?
Yeah, it's basically instead of loading everything at once, which to be honest with you is fine if you've got a very small table, for example. But if you have a large, say, transactional table that's updated every single day with a large volume of data, you're not going to want to reload that entire large table at once. So what you can do is set up what's known as incremental load strategy, where it will only load updates from the last load. So for example, first of all, you can load an entire table in the beginning. And then after a while, when that table's got some more updates in it, you actually only load those particular updates. And this is a very common strategy for those that work with ETL or ELT.
Yeah, seems to be very legit because on the one hand, they are asking for something where we have large tables and large volumes of tables. And I think this makes total sense. If we're thinking about a large table and maybe only 1% of the data in this table is changing, then you are just loading 99% of the same data over and over again, which doesn't make any sense.
Yeah.
So, okay, B will be one of our answers. Awesome. So let's think the next thing would be manually partition the fact table. So there are 2 things to this. First of all, what is a fact table, Kevin?
A fact table is basically a table that contains all your measures, effectively, all your truths. So especially, it's a very common thing to do, especially when you're working for, say, for example, star schemas. You will have these fact tables within them, which contain all of your main metrics or your main measures, or, for example, numeric values. So a good example of this is like if you got a fact table for sales, it would contain the sales totals, etc.
Okay, and in this star schema, the fact table is where more or less the dynamic data is, and the dimensions is where the not so dynamic data is, which doesn't say that the dimension tables are not dynamic at all, because this is we discussed this in some other episode about slowly changing dimensions, right? But the fact table is where all the changes, like you said, maybe all the sales or something like this is in there. Okay, so now we know what a fact table is, but can you tell a little little bit about partitioning. So what's meant with this?
Yeah, partitioning is where you logically split a table up by certain criteria. So a very popular thing is for people to partition by years or by a combination of months, for example. And the idea is you partition it, and then when you go to query a particular table, the query will be more efficient because you can do what's known as partition or query elimination. So it knows which partitions to query.
Okay.
However,
and if you're thinking about this, then I think it makes most sense to have a look at how the majority of the queries is, right? To find a partition strategy which deals with this. Because, for example, if the majority of all queries is like queries which are only within 1 year, then it just would make sense to partition by year, because in this case, it knows that all of the data for this special year is in this special partition. It will not look, for example, if you're querying data for 2026, right? Then it will not look in a table in the partition for 2024 or 2027 or something like this, and then the amount of data that will be queried will be condensed by this anyway, because it only looks at the data in the partition for 2026. Okay, awesome. So what do you think about C, manual partitioning the fact table, after we know what partitioning and what a fact table is?
partitioning is effective if you're doing queries, for example, but it's more for the actual queries themselves as opposed to actually dealing with the ETL process and decreasing the resources during that process. So whereas it is good for queries, is not really, I don't think, suitable for this particular question.
Yeah, okay. So let's move on to D, is switch Azure Data Factory for ETL. So we know and we love Azure Data Factory for long years. So what we could just do is let's take this, because this is a proven approach, right?
Yeah, well, okay. So the reality is Azure Data Factory is a very mature product to do your loading outside of Microsoft Fabric. It's been around for many years. You use it to perform ETL and ELT to a variety of services, as well as Microsoft Fabric, which the support is there for, I must stress. But also for other offerings as well, including other Spark Compute related offerings, etc.
Okay.
Yeah, without saying too much, of course, but we all know it's very popular for ETL and ELT. Yeah. So yeah, I mean, you could look to use Azure Data Factory. You could look to twist a few performance tweaks here and there. Maybe potentially it can be faster way. You can maybe boost performance. But as far as decreased resource usage is concerned, you're taking it out of Fabric. So technically you would decrease the resource usage for Fabric. But then, of course, you would have the actual cost of working with Azure Data Factory, etc., etc.
So we are replacing something which is already included in Fabric with something outside, and we have to pay extra.
Yeah, you will still have to pay, essentially. And if you're still doing a full load of that data, it's still going to happen, that full load, if you even move it to Azure Data Factory. And you're actually making it a bit more complex as well, because you're actually taking it out of the Fabric environment. Right.
Okay, so well, then there's only one answer left, and this answer is about use change data capture, CDC, for tracking changes. How do we feel about this? And what is change data capture, Kevin?
It's exactly what it says on the tin, pretty much. So if you're using certain, for example, it's very popular within database management systems at this moment in time. What you can do is enable change data capture, and then just like with other incremental load mechanisms, and this does help with incremental load, of course, it will track all the changes that occur. And then when you need to actually do a load from that database in question, you will only load the changes that have occurred over time.
Okay.
So it's essentially another incremental load strategy.
So can we see it like this, that implementing an incremental load strategy is about the schema or the what we should do, and the change data capture is the actual implementation of this?
For some systems, then definitely, because obviously you can't use CDC for every single system, but for the ones that do support it, you will use CDC as part of your incremental load strategy, to be honest. So I think
Awesome.
we figured out by process of elimination which two are the correct answers here.
Okay, cool. So the correct answers are B and E, right? And this is another mystery we solved. So any last words, Kevin? Anything you like to add to this specific topic?
I think immediately springs to mind, as you could tell when we were doing the process of elimination. I have thoughts about the other answers as well, about how they can be used and can be utilized.
Exactly.
But that is my final thoughts at this moment in time. Obviously, the answers are out there, and in this case, the answers are B and E. So,
okay. Yeah, awesome. So we are done for this episode again. So thank you very much, Kevin. And to all our listeners, beware, because some change data capture might be out there, right? Bye-bye.
thanks, so, bye.